Today, me together with my virtual Sergey will be speaking about Java and vulnerability research in Java. So, couple words about our team, me and Sergey. This is us playing the CTF here in the ThreadCon in 2018. So we decided to participate in the CTF activities just, randomly, and first it started like as a fun activity, and then we took like the third place and the second, and finally we won the first place in the CTF in 2018. Woo! Yeah, that was a really fun exercise. Together with Sergey, we have more than 25 years of vulnerability research and security activities. We have really hundreds of vulnerabilities and CVEs, so as soon as we started paying a lot of attention to fuzzing and we started studying this, let's say, deep and extremely interesting field, we started getting a lot of vulnerabilities, a lot of crashes and stuff like that. We've been studying and improving our fuzzing skills for, I think, 3 or 4 years already. We did zero-day exploitation research. Basically, when you are detecting a zero-day exploitation in the wild, so you have to understand how that zero-day was exploited. For example, the previous talk by Mr. Han was, he mentioned that there's WannaCry ransomware. You remember WannaCry? Okay, good. So back in the days, we have found a zero-day vulnerability in a WannaCry, but it's not a public talk. So if you want to know more details, we can discuss it later. Yeah, we found the vulnerability in the command and control infrastructure of the WannaCry. We've been doing different and many vulnerability research exercises in non-typical IT environment. We've been exploiting vulnerabilities in different cars and autonomous vehicles. Plenty of smart things like smart road infrastructure, smart cities, so cameras and stuff like that. Industrial control systems, this is the main activity for me and my team right now. So we've been exploiting ICS environment for, I think, 11 years already. Industrial Internet of Things, operating systems and stuff like that. We've been studying a lot of things about how to improve your fuzzing, how to improve your mutation mechanisms. And yeah, me and Sergey, we do have a custom offensive security trainings about the fuzzing, vulnerability research and supply chain security. And that's us after we won the first place. All right, so I have a couple of questions for you to better understand my talk. So again, this is the first time where me and my virtual Sergey we're giving this presentation. So if I will be doing some stupid things, please forgive me. Okay, so you know what is the fuzzing? Who uses fuzzing in day-to-day activities? Raise your hands. Okay, QA is not fuzzing. We will be talking about this a little bit later. So, good. No one uses it. All right. And I guess no one uses the clusters for fuzzing, okay? And does your business or management understand that fuzzing is important? There is a business guy. You know what's the fuzzing? No. And you don't understand why it is important? Not yet. Okay, not yet. I hope you will understand. Cool. So fuzzing is a very common security approach. This is the part of the software security development lifecycle. This is basically a offensive strategy. When you take your, let's say, software, your product, your protocol, whatever you do, whatever your product team does, and you try to input some either dummy or mutated or funky data into this, let's say, software, right? The goal of the fuzzing is very simple, is try to strike your application or your creature in a way and try to make it behave irregularly. And yeah, you throw different type of data, unexpected data, long data, short data, I don't know, integers or whatever you want. This is like a very, very simple approach. The OWASP has a very good definition for fuzzing, fuzz testing. So, and it was developed by a University of Wisconsin in 1989. So this technology has been for a while on the market. And yes, as I mentioned, the fuzzing is the part of the security software development lifecycle. So this is a very important part. So basically, every time when you do a software, you need to fuzz it. You need to fuzz it a lot. And in the best case scenario, you need to do fuzzing like 24/7, like okie dokie. What can be fuzzed? Pretty much everything. So you can do like fuzzing against all your technologies, protocols, fonts, different files, file extensions, basically any kind of data parser. So if you do have like XML reader, go fuzz it. If you do have like a tool that processes your JPEG or BMP files, go and just fuzz it. I'm pretty sure you will find a lot of vulnerabilities. There are several approaches for the fuzzing. There's like a black box fuzzing, white box fuzzing, and the gray box fuzzing, something like a man in the middle. Black box, when you do not know anything about the product that you are fuzzing. Imagine you are a vulnerability researcher or you are a bug bounty hunter and you have a tool that you need to attack. So this is the case of the black box fuzzing. So you do not know anything and you try to understand the communication protocols, you try to understand how to interact with that kind of software and what kind of data should be provided as the input and what you should get as the output data. The white box is pretty much different, right? So you have everything. You have source code, you have documentation, you have like everything, you understand how this tool works. But the enterprise level solutions, if you take a look on the source code, it's a mess. It's just like, it's a salad of everything. Like the code cannot be understandable. And here we will be touching a topic of the QA and static code analysis, code review and stuff like that. And the gray box is when you have a limited information about the tool that you are researching. For example, you have a binary file and you have some documentation. You know what's the input data. So this is something like you know, but not too much. And now, what is the difference between the fuzzing and any kind of QA practices like a unit tests and stuff like that? Yesterday on the, let's say on the speaker pre-party, we were discussing the topic of the difference between unit tests and the fuzzing. I don't know if this person here in the room, we were drinking yesterday and discussing fuzzing? No? Okay, good. So the thing is that when you're using the any kind of QA practices like unit tests, you are testing the code quality. This is very important. So you test if the code works or does not work. That's it. You have a limited number of tests that you are going through and you just need to understand if your code works based on the documentation. That's it. The fuzzing is all about security. When you are doing the fuzzing practices, you are trying to find vulnerabilities. When you try to make your binary file or any other kind of application to work in a different way. So basically, this is the major difference. Fuzzing is about security and the vulnerability research. The QA practices is all about the quality of your code. Let's talk about the input data and what kind of data we can provide during the fuzzing things. So there are two big groups of the data. The first one is just a simple generated data. So sometimes when you are doing the bug bounty hunting and stuff like that, you try to brute force different subdomains or directories and stuff like that. You take a word list and you go through that word list and you try to brute force that subdomains, for example. The same for the fuzzing. The very simple and dummy approach, if you take the word list, pre-made word list, generated word list, and just use it as the input data. Sometimes you use not only the word list, but just generated data. For example, if you do the fuzzing of the let's say HTML parser, right, you will just try to use different dummy data, like provide binary instead of text file, instead of just the text data, and so on and so forth. And the second group here is the mutated data. This is very interesting. The difference between the generated and mutated data is basically when you use a dummy data and the smart data. In the mutated data, you try to understand the feedback from your application and then do mutations or changes in your, let's say, input data based on the feedback. Here in the mutated data, right now a lot of people are trying to play with the machine learning algorithms to increase your coverage, to make your fuzzer works better, and so on and so forth. We also do this thing. Well, right now fuzzing looks pretty much as this kind of simple exercise. So what is the structure of the fuzzing? It's kind of simple. You have like only 6-7 major steps. Well, first you need to understand your target, what you will be researching. The second, you need to try to understand what are the inputs. What is the input data? What is the language? What is the protocol? What is basically how to properly communicate with your target. Third, generate mutated data, or create a word list or whatever you want. So you need to, when you understand the language, how to talk to your, let's say, application, you start building the the data set that you will provide as the input data. Well, then you execute the data. You just start throwing the data, and after that you monitor the behavior of your application. Super simple. After monitoring the behavior of your application, you have a pretty big set of logs, or basically results of your fuzzer. And after that you need to parse it and understand if there are any like vulnerabilities or any useful information for you. There are several approaches to automate the whole process. So by the end of the day, you will get a valid output that can be transferred to exploit easily. But let's take a look. Let's take a closer look on the classical fuzzer. The whole chain looks simple, but the structure is not that simple. Fuzzer usually, the fuzzing approach contains of the several important things. Corpus basically interacts with the it interacts with the fuzzing engine. You can use either open source solutions, you can build your own, like whatever you want. You have your target, you have a library, you have sanitizers. Sanitizers basically is the part of the fuzzer that validates if there is a valid crash or not. And you have your results. Very important. When you just download your first fuzzer and you try to run your first fuzzer and you think you understand, you look like this tiny little cat. So you just, click a button, you start fuzzing, and you're like, hey, where are all my 0 days? Well, unfortunately, you will not get like the 0 days straight from the box. You need to better understand how to talk to the application. You need to customize your fuzzer properly to get a better input. There are two limitations right now currently in fuzzing approaches. You either need to pick one of them. First one is time. Fuzzing takes time. You need to run, for example, for several days a fuzzer if you want to get a valid results. And the second limitation is coverage. So if you want to cover the whole code base of your application, you need a lot of time. If you are limited in time, you will not have the good coverage. We were researching this problem for quite some time, and we have found several tricks how you can increase your speed and increase coverage at the same time on the limited hardware. So if you have like unlimited hardware, for example, you work in a Google company or Facebook or any other like big enterprise company, you have like almost unlimited resources for your fuzzing engines. So you can have like amazing coverage and amazing and short time for that coverage. So if you implement several tricks, you know how to extract data, you know how to get your sweet and juicy 0 days, and you're happy. Now I think you have the basic knowledge of the what is fuzzing, why do you need it, and so on and so forth. And now back to the major topic, Java fuzzing. Who knows what is Java? I personally hate Java. I used to be a software developer for some time, and we were developing like one of the solutions, and we were programming on Java, and I hate it. That's why we decided to attack Java. Okay, 2 disclaimers. First one is this is only educational material. Today I will be showing you a explanation and let's say a demo of one of the CVEs that we have found recently in one open source, and we will be releasing, it's actually already released. Last night we have prepared a demo, so you can go to the GitHub or GitLab and download the tool, play with code, play with the fuzzer, and see that, you know, how we have found that vulnerability. I kindly ask you to be good, not to be bad, to strictly follow responsible disclosure policies. If you find any 0-day vulnerability, please report it to the vendor. Please report it to the vendor. And the second, our final goal usually is to find either remote code execution or local privilege escalation. Those are like 2 top vulnerabilities that we're usually looking for. Especially if you find a logical remote code execution or logical local privilege escalation, that's like best out of best. The rest also counts, like DOS, DOS vulnerabilities. They are super critical, especially how Mr. Heng was talking about critical infrastructure. So DOS is like super critical, or for payment systems. Java. What do we know about Java? You know the screenshot? 3 billion devices run Java. This screenshot appeared, I think, in 2008 or something like that, or maybe 2003 or something. Anyway, and since that time, they always say like, oh, 3 billion devices, 3 billion devices. But in fact, no, I think that there are more devices than 3 billion. So what do you think? Is Java popular? Yeah, it is super popular. So if we will take a look on the statistics, it says that the Java takes the 2nd place of the popularity. Usually, if you will take a look on the enterprise code, the core, the major functionality is based on Java. And everything around it, you can have like PHP, HTML, Python, like you name it, like all the other technologies. Every tiny little startup or big enterprise companies, they create their own development stacks as crazy. So Java is popular. Python is also popular because you can, you know, use it almost everywhere. Let's talk about the Java and the other fuzzing approaches. Why we decided to pay attention on the Java fuzzing itself? Because you can basically take AFL, like American Fuzzy Loop, that's one of the most popular fuzzing frameworks, and try to fuzz pretty much whatever you can. But no, Java is from, let's say, from the different planet. If we're talking about the classical binary file, you expect, you know, application just to crash, shut down, and after that you do the analysis of the crash, you see the state of the memory, you try to understand if there are any like binary protections and blah 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 blah. And sometimes, only sometimes, these crashes, they help us to catch different types of the vulnerabilities. DOS, LP, RC, like remote code executions, and so on, and so forth. In Java, it's a little bit different. So if you have kind of buffer overflow or integer overflow, for Java this is not a error. This is only exception. and it can be exception by design. And it does not bring you immediately remote code execution, because, for example, in the classical binary file, if you have like, I don't know, heap corruption, you can, you can build, let's say, a trail between the heap corruption and remote code execution. You need to pay some time to research it, but well, you might succeed. You might have success. But in Java, it's different, and that's the major concern that we have found. Why do we believe that it is very important to research Java and to start, fuzzing Java? First of all, again, it is very popular. It's pretty much everywhere. There is a chance that you can find the vulnerability in JVM. You know what's the JVM, Java Virtual Machine? The chance is really small, but there is always a chance. The good thing for us, for researchers, that Java uses native libraries. So the native libraries is the, let's say, third-party libraries, not developed by Oracle, and they can be, integrated. Those third-party libraries can be like, I don't know, CRC32, Zip, or any other things. Yeah, relatively often you can find a class like Sun, MISC, and unsafe, and basically, yeah, this is an example of unsafe memory usage, like memcpy, or like free, or malloc, or any other pretty known unsafe memory usage. And yeah, basically, this is a direct trail to exploit pretty cool vulnerabilities. If we're talking about the network applications, it's also interesting and important to research Java, because if we find, let's say, infinite loop in Java application, and this is like a server-side application located in some like pretty cool infrastructure, that can be a cool attack point for you, and a pretty critical vulnerability for the asset owner. So, for example, today we will be looking at one of the infinite loops. And what is the point? If you find the infinite loop, you can load the microprocessor pretty bad, and so the whole server can be shut down. So, in this case, if we will take a look on the level of the criticality of this vulnerability, it's not that critical. It will be like around like 6.5 or 7.5. Based on the CVSS metrics, CVSS score, but for the business it will be super critical. Logical vulnerabilities, we love them, we need them. We had several examples when we have found a local privilege escalation, logical local privilege escalation, and logical remote code executions. Why it is bad? You always try to detect using several behavioral patterns. I don't know, you can use Yara rules, you can use snort rules, or any other kind of detection mechanisms to detect a binary exploitation. So you have a binary string, and based on that binary string you try to detect the exploitation. If we have logical vulnerabilities, they are quite heavy to detect, because you have built-in logic, a valid logic, a valid functionality, and with this valid functionality you're exploiting, for example, remote code execution. So if you will be creating a let's say a detection rule based on the Yara or snort rules, you might get false positives, because if it's like a valid logic and this logic is used by the valid application, that might be a problem for you. And logical vulnerabilities, here on the slide I have an example of the SQL injection. Usually if you try to fuzz some, I don't know, some parsers, you might get the SQL injection. But the thing is that those SQL injections cannot be found outside of the tool. So if you try to exploit the SQL injection through the web browser or any other kind of, I don't know, interaction point, you try to use SQL map or any other automated tools, you will not find this, because this is another type of communication. I will bring you an example. For let's say you have an application where you upload a BMP file, right? Just a picture. If you try to use a fuzzing approach, you try to generate different types of the corrupted BMP files and try to feed these BMP files to your target application, you will start getting crashes. And one of the crashes will show you the SQL error. You will not find this SQL error if you will be doing a web vulnerability research, if you will run the SQL map or something like that. No, zero chances. And that SQL injection might bring you like a really good results if you're doing a penetration testing activities or like vulnerability research. This is a real case example. So yeah, in your output you will get like, hey, you have like SQL error in syntax and blah blah blah. Take a look at this value. Couple more important things about the fuzzing. Let's have a quick look. This is not only about the Java fuzzing, but we also need to know it. So one important thing that I wanted to tell you is that, yeah, the fuzzing approach must tolerate any kind of input. So your fuzzer need to provide all kinds of like input data. It cannot, exit on the, on any input. So you need to continue working. The fuzzer should be fast. This is, again, as I mentioned, this is one of the concerns of the modern fuzzers. You either have a good coverage or you create like a fast fuzzer. And some other important thing. Now, Java fuzzing. There are two good existing products right now. They are open source. This is very important, so you can download it and play with the source code and try to understand how it works. JQF, so it's available on the GitHub. Using this framework, as far as I know, researchers have found like many cool vulnerabilities in like Google products, in OpenJDK. You know what's the OpenJDK? Java development tool. Okay, cool. In Mozilla Engine, Apache, different kind of Apache applications, libraries, and so on and so forth. Different parsers like Apache PDF box, and so on and so forth. And Jazzer. So today we will be talking about Jazzer. Also, Jazzer was used to find different vulnerabilities in different parsers, common compress, and again PDF walks, and so on and so forth. And there are two cool vulnerabilities, two CVEs. We wanted to talk about both of them, but unfortunately Sergey didn't come, so today we have like a shorter version of the presentation. So today we'll be talking about the second vulnerability in Apache Xerxes Java. So this is XML parser. It was created for, as far as I remember, for C implementation and Java, of course. And we have found a pretty interesting DOS. So in general, if you will start doing fuzzing, I highly recommend you to start doing fuzzing. This is a really cool thing and very challenging. And if you will focus on the Java fuzzing, I highly recommend you to take a look on the two important things, Jazzer and the lib fuzzer. So basically Jazzer is the additional thing for the lib fuzzer. Do you know what's the lib fuzzer? Okay, you will read about lib fuzzer. This is a really cool let's say framework developed, as far as I remember, by Google security team. And this is like the most promising combo right now. So, but these thoughts are based on our own experience. We were using libfuzzer to do the vulnerability research in different, mostly binary files, binary applications. But if you combine it with the Jazzer, it works pretty cool. There are also several interesting combined approaches. So you can use, you can fuzz Java virtual machine logics, including together with native libraries. So those are non-Java libraries that used by a system like C, C++, or DLLs or any other external things. So basically, if you take external library and put it into Java virtual machine, you can find pretty cool results in how the JVM logics works with those kind of binary files. Sanitizers. So Jazzer has built-in sanitizers. You're very welcome to create your own sanitizers. What are the sanitizers? As I mentioned earlier, those are, let's say, parts of the fuzzer that help you to understand if there is a valid crash or not. So if the application has crashed. And those built-in sanitizers, they are super useful. So for example, LDAP injection. So if you're fuzzing like different LDAP implementations, that will be like a perfect spot for you. Operating system command injections, regex injections, SQL injections. So basically, as the starting point for the beginners, this is like a pretty cool setup, and you can just start playing with it. You can download simple application, open source application, and start doing the white box fuzzing and so on and so forth. The good thing about the Jazzer that it is super flexible. So you can modify it based on your needs. You can modify what kind of exceptions you would like to catch, what kind of messages you want to filter, and so on and so forth. And this kind of functionality helps you to set, let's say, traps on the catch block, so you try to catch different exceptions. And in those exceptions, you might find a perfect dose, like vulnerability when your application crashes, or infinite loops, or sometimes even remote code executions. But for usually for remote code executions, you need to do additional research and try to understand how to exploit the vulnerability properly. And now let's have a quick look on the this vulnerability that I was talking about. It has a CVE-2022-23437. So, as I mentioned earlier, this is a DOS vulnerability in Xerces, Apache Xerces. This is XML parser. And basically, what do? You are sending a special crafted network packet, special crafted XML file, and your application, your server application, just does not respond any kind of messages, and basically the whole server just shuts down because it runs out of CPU resources. So you can take a look on this application using this link, xercesapache.org, and blah blah blah. So very important thing. This library comes with most of the GDKs, OpenGDK and other variations, and this library was not written by Oracle. So this is it belongs to Apache. So here's the thing. This is like one of the common problems of the all open source software. Usually open source, usually people trust open source, but open source contains huge number of vulnerabilities. If you find a vulnerability in an open source solution, most likely this vulnerability will be exploited in the enterprise solutions, because how does the typical software engineer work? Take the open source and bring it to the enterprise. That's it, without checking if it is secure or not. Usually people just blindly trust the open source software and like, oh, okay, this is like a community edition. Probably someone else checked the vulnerability state of this code, but no one checks the vulnerabilities. If you will take a look on the attack vector, so the final score, CVSS score, is not that high. It's 6.5, so it's medium. But for the enterprise solutions, this vulnerability is critical. If you start exploiting this vulnerability like constantly, you will just shut down someone's server for pretty long time. And now let's switch to a boring part, the source code. So this is the example of the source code from the vulnerable library. We have provided let's say a simple version of it. This QR code, this one, brings you to the original vulnerable open source. If anyone from this room can spot a vulnerability by doing a code analysis with your own eyes, I will pay you $50, really. If you do it, no, really. That source code is just is a mess. I mean, it's like a salad of everything. You will spend a lot of time, believe me, a lot of time trying to understand where is the vulnerability, especially this kind of vulnerability. So this bug was found by a fuzzing approach. And yeah, I'm giving you like a small hint. So if you open this source code from the QR code, you will just need to look for this string, like public int scan literal and blah 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 blah. So after this string there is like a vulnerability somewhere, but I'm not sure that I cannot find that vulnerability like with my own eyes, because I will just get bored. This is a simple version of the source code with containing vulnerability, and let's take a look. I will give you a link on the fuzzer on this demo setup, so you can download it and play it and find the kind of vulnerability. So when you're running the script, you always need to include some like dependencies, like instrumentations and parameters. It's kind of simple, so we built, let's say, a very, very simple corpus for your fuzzer. And you just click, boom, the button. So you start looking for vulnerabilities. Fuzzing takes some time, but this fuzzer and this code can be run on pretty much every computer. So don't worry, you don't need like a super heavyweight computer to process this vulnerability. It takes around like 10 minutes or something like that. And after 10 minutes, it gets to infinite loop. So this particular version, let me see. Oh, not on this screenshot. But in this particular version, you need. Okay, yeah, there is 20-minute limitation. So in this particular version, if the fuzzer does not respond for 20 minutes, like 12,000 seconds, in this case, it just automatically shuts down. You can use a different number. You can put like 10 minutes, 20, 30, or whatever you want. But so if the fuzzer gets to infinite loop, in this case, it automatically shuts down and it writes the result into like one of the folders. So basically, what does it mean in this particular example? You take this output file, this generated file was created like last night, so we decided to test this fuzzer before releasing it to open source. And you take this payload and you can try to send this payload to a valid application and it will crash. So it will get an infinite loop and will just, stop responding. One more important thing, this vulnerability was fixed. The fix is available, and the source code that we are providing, the target source code, is for the vulnerable version. I mean, this is like an outdated version. But you are always welcome to start vulnerability research on the current and modern versions. So as you can see here, this is the output of the payload, and yeah, this is the QR code of the of our fuzzer. Please feel free; it is already publicly available, so it's on the GitLab /wasp. If anyone of you watched the Futurama cartoon, do you know what's the space wasp? Okay, whatever. And yeah, so this is the demo of our fuzzer. We have created this fuzzer for Docker. A very important thing. If you're doing a vulnerability research for quite a long time, you will find one interesting problem. If you're fuzzing or doing the vulnerability research on non-isolated environment, you will see one interesting example. You're reporting vulnerability to a vendor, and vendor says, hey, we know this crash, we received this crash a couple days ago, don't worry, the CVE does not belong to you. Why does it happen? Because almost every software sends statistics to remote servers when the application is crashed. So if you're doing vulnerability research, do it on isolated environment without network access. In this way, you will be able to keep your, let's say, findings and report it to the vendor directly. That's why this demo has a, let's say, a Docker container. And yeah, some conclusions. First of all, the fuzzing is one of the most important and the most promising security practices existing right now. Believe me, in 5 to 7 years, fuzzing will be implemented almost everywhere. Right now, big companies are investing a lot of resources, money, time, and other things into fuzzing, and they're releasing like open source so people can just take the fuzzer and start fuzzing. The second important thing, the implementation, the combination of the fuzzing techniques and the machine learning will bring amazing results, believe me. Fuzzing right now is the part, as I mentioned, of the security development lifecycle. It must be a part of the security development lifecycle because it will limit the scope of the possible vulnerabilities in future for your products. Third important topic is that Java is still everywhere. For good or bad, I don't know, but it's still everywhere. And if you are doing vulnerability research, please pay your attention to Java. If you do static analysis, dynamic analysis, whatever, but keep your eye on the Java. Third-party libraries is the big problem, not only for the Java. It's a big problem right now. The supply chain security is like, no one knows how to solve this problem, really. And the part of the supply chain security is the third-party libraries usage. You either need to have like a gigantic number of people to constantly do the vulnerability research of all the third-party libraries, or you need to invest a little bit of time and resources into like a small team who will be constantly doing the fuzzing on all of your dependencies, on all of your third-party libraries, and this will, believe me, this will solve a lot of problems for you. And yeah, fuzzing is fun, really. You get amazing and unexpected results from the fuzzing, and sometimes you take a look on the crash and says like, wow, that was unexpected. And yeah, that's a really fun activity. And that's us, me and my virtual Sergey, who is at home right now, unfortunately. If you have like any questions, feel free to ask right now, or you can reach us using all the communication channels and so on and so forth. Thank you.